All right, so let's move on to topic 5, which has to do with the conic form of a parabola, focusing particularly on focus and directrix. As a reminder, when we're talking about the geometric definition of a parabola is the set of points that's equidistant from a point and a line. So if I have a parabola here, then within the parabola, but lying on the axis of symmetry, I'll have my focus and then my vertex. And then underneath it, that's actually a really big dot. That directrix should not be touching the parabola. So you always end up with something that looks, I'm going to draw a different one that's slightly better. And I'll make this one go a different direction. Vertex, focus, directrix, something like this. So if you are asked to write the equation of a parabola with a vertex at the origin and a focus at 4, 0. And now in case somebody's looking at this later, I'm going to get rid of this picture that has nothing to do with this problem. I'm going to go ahead and sketch a graph. It is really important with these. My experience is people tend to get them right when you draw a picture and tend to get them wrong if you don't. So we're going to put the vertex at 0, 0 and a focus at 4, 0. So what that tells us immediately is that this parabola has to open to the right because the focus, it's kind of like Pac-Man, the focus has to be inside the parabola. If a parabola opens to the right, we're using the form y minus k squared equals 4p x minus h. Now in this case, the h and the k are both 0, 0. So we have y squared is equal to 4p x. The p is the distance from the vertex to the focus, this part. So if I'm moving to the right, that's a positive 4. Had it been going to the left, it would be a negative 4. So 4 times 4, x, and y squared equals 16x. Now I want to do another one. This one was not on your study guide, but this is another example. Just to make one that goes a different direction. This time I'm going to put the focus at 0, negative 4, and the vertex at the origin. If I sketch that one, and this one I'm not even going to try to make even pretty into scale, 0, 0 is the vertex, and this is negative 0, negative 4 because I say so. If that's my focus, this parabola has to open down, which means that my form that I'm fitting is x minus h squared. So I'm changing which term was the squared term, equals 4p y minus k. I still have 0, 0 for the h and the k. This time, my p is negative 4 because I'm going down. Down and to the left are both negatives. Up and to the right are both positives. So then 4 times negative 4x, or y, excuse me, I just wrote the wrong thing. And then we have x squared equals negative 16y. All right, now let's look at the problem that's actually on your paper. And I want to talk a little bit about how this is one of the places where it is actually super useful to know how to complete the square. So the problem says to rewrite the equation y squared plus 6y plus 8x minus 15 equals 0 in conic form. And then we're going to find the vertex, the focus, and the directrix. Now, when I look at this, I know it's a parabola because I see the y squared. Because it's y squared, I know it either opens up or down. But I'm going to need a minute to figure out which, because it's y squared, I know it either opens left or right. If that had been x squared, it either opens up or down. Now, if this was already, if it was already written so that it goes up or down, it might work just as well for you to put it in standard form, solve for y, and then find the vertex. Since this is a left or right parabola, and we don't have as much experience manipulating those, this is a good time to try to complete the square, keeping in mind that what we want is y minus k squared equals 4p x minus h ultimately. So I need the y part to be a perfect square. So if I look here, I need this part to be a perfect square. And I need the x and the constant to be on the other side. So I'm going to subtract the 8x and add 15 from both sides. And the reason I'm doing this is to make a perfect square, something that I can complete and make a perfect square on the left. Now, if I'm looking for what number can I put in this hole to complete this square, take the 6, cut it in half. 6 divided by 2 is 3, and then square it. What I need to make that a perfect square is a 9. But if I have put a 9 on the left in order to keep it balanced, I have to put that same 9 on the right. Now I have a perfect square, so I can make this y plus 3 squared. Now, to make it fit this form, I need x minus h to be in parentheses. I need to have factored out a GCF. Anything that's in front of that 8 needs to come out. Negative 8 gets factored out, and this becomes x minus 3. Now, when I look at this, I'm going to look for my vertex. So I need hk to be my vertex. H is 3. K is negative 3, because remember in the form, it's y minus k. So this will be 3, negative 3 for my vertex. Now, for the focus in the directrix, it's going to be easier if we go ahead and draw the picture. Here's 3, negative 3, and I'm not at all worried about scale. This number is negative, and I know the y squared is telling me to go left or right. So if I know the y is squared, left or right, if this is negative, I know I want this parabola to go to the left. It's a really badly drawn parabola, but just go with it. Then I'm going to take this, the negative 8, and say 4p equals negative 8, which means p is equal to negative 2. So if this opens to the left, I'm moving to the left 2 to get to my focus. That means I'm keeping the y coordinate of my vertex, but my x coordinate has gone to the left 2 from 3 to 1. For my directrix, I need to go 2 to the right, and it needs to be a line. This is a vertical line, so I'm going to call that x equals, if I've moved 2 units over, 5, 3 plus 2. And that's it.